Now, generators. Okay. Now, generators is another optimization technique available in your Python. Okay. So now generator is actually optimization for your functions. Okay. So a generator will actually give me lazy execution. Okay. So how it will work is, let's say you want to generate 1000 prime numbers or a Fibonacci series of 1000 numbers, something like this, right? You will not actually work on 1000 numbers in a single go. So you will need it in a step-by-step manner, right? So instead of, so if you write normal function definition, okay, how it works, it will give a call to this particular function and it will execute this entire function, right, at once. Okay. So now if it's memory intensive operation, so you can see there is some lag and your program is halted. Okay. But your case is you will not use all such numbers at one go. Okay. So in that case, you can go with your generators. Okay. So it will give you numbers one by one. Okay. We'll try to see in case of a Fibonacci series. Okay. So we'll write a function which will infinitely give Fibonacci numbers. Okay. But from this, I want selective reach. Okay. So I'm writing a normal Fibonacci function. So I'm say def Fibo, let's say. Okay. It will not take any parameter. So my expectation is it should generate something like 1, 2, 1, 1, and 2, then 3, then 5, 8, continuously, something like that. I'm initializing two variables, that is first num equals to 0, second num is equals to 1. Okay. Initially, let's say next number is equals to also. Oh, we don't need this. I want to work on this infinitely, so I'm saying while true. Okay. Keep in mind, I'm writing an infinite function. Okay. So what this function should do, it will calculate the next value. So next value will be my first number plus second number. Okay. This is my output. Okay. Now instead of writing the return statement, okay, or adding it to a list, okay, I am saying leave. Okay. And I'm swapping these two things now. First number, first. I should say first number and the second number is equals to now second number, comma, next value. I'm here and I'm giving a call to I want let's say first 20 numbers in that case. Okay. So yeah.
What does yield do?
Oh yeah, we'll discuss this. Hold on.
Okay.
So each time if I give a call to this particular function, it should generate me one Fibonacci number. Okay. Now I'm writing something like this. G of Fibon. Okay. I want 20, that's what I'm saying. Okay. And I'm giving things, let's say next.
is a function.
Exactly. So it will display. So what I have done, okay? So I have given a call to this particular function, and it contains a statement called yield. Okay. Now whenever I say a yield, which means this is now a generator function. Okay. So that is the only difference you will see in your yield and your return statement. Okay. So instead of writing return statements, which will come back to this, I'm writing yield statement. Okay. So whenever there is a yield, actually it gives me a generator object. Okay. So each time now when I give a call to this next function, okay, so there is a function called next. Okay. When I say next of G, at that time actually it will start the execution of your function. Okay. And it will execute from first statement till it encounters the first yield statement. Okay. So I'm writing G Fibo of next of. I got 1. Okay. Next time I'm writing, it is giving me 2. Okay. So the next time the way it will work is, it will, so generator function, the speciality is, in case of a normal function, when call is passed to this function, it will execute the entire function and it will come back to this call, right? It will not maintain the state of local variable. It will not maintain the state of this particular function. Generator on the other hand, it will maintain the state of all your variables. Okay. So whenever you give a next function call, okay, using this next, it will start from this yield statement, okay, till it encounters next yield statement. Okay. Now this is my loop, right? In first go it executed till this, and it has given me 1 Fibonacci number. Okay. Next time when I say next, at that time it will start execution of this, and then it will check the condition. Okay. So this is infinite loop, so it will go again, but it will again stop at the next yield statement. Okay. So if I say next again, it will start from where it left till it encounters the next yield. Yeah. Yeah. So whenever you need lazy execution, whenever you need an infinite number of series, we can use this generator function. Okay. So whenever I give a call to such function, it actually gives me a generator object. Okay.
Then we have you use this.
Mhm.
So when it comes to you, it actually breaks.
It will stop. Yeah.
That time. Or breaks suspended.
Yeah, suspended, we can say. That will be the better word. Yeah.
So until the next.
So once you give a next call again, it will start from where it left till the next yield.
Okay. So will it have the set of all the variables?
Yes.
Suppose you call a function inside the while. Is it possible?
Yeah. Yeah.
If you execute the function, set the value, then you come to again stop with the yield.
So the basic concept is this: start from yield to go till next yield. That's it. Now, same like return, I do not have a restriction that I can write only single yield statement. Okay, I can write 2 yield statement also. So here, if I try same yield again next value. Okay. So now if you see, if I give a first call, what should I get? 1. Okay. If I give a next yield, this is again giving me 1. Okay. In the next yield call, this will give me the next Fibonacci number. If I again give a next, it will give me the 2 again. Okay. So I can have n number of yield statements.
But why there is because of 2 yield, 1 income
so I calculated first num, second num, I calculate next value. Initially my next value will be 1. Right?
Because it's yield.
So I'm saying yield. This is my first next. Done. When I say second next, I said it will start from this yield till it found the next yield seed. This is my next yield, and I am asking for next value. Now the value of this next value is still 1. Okay, that's why I will get 1 only. Okay, again when I say again next, it will start here, it will change your first num, second num, it will swap it, and it will calculate the new next value. That's why you are getting 2. Now again there is a yield, that's why it will again give me this 2. So in short, I'm getting the same number again and again. Okay, so concept is it will start from one yield statement, it will continue till it encounters the next yield statement. Okay, and you can have n number of yield statements. Okay, so another interesting part, I am saying generate Fibonacci numbers from 1 to, let's say generate me only 3 Fibonacci numbers. Okay, next time I am saying generating 5 Fibonacci numbers. Okay, so you can say it is not starting again from beginning. So these are 1, 2, 3 from first, okay, then 1, 2, 3, 4, and 5 from the second. So it will continue from where it actually left. Okay. So this is the concept of generator. Okay. Another thing. Okay. Generator will throw an exception if it runs out of the numbers. Okay. So let's take another example. I'm writing this another definition. Let's say just to print. Okay.
Yeah, they are very intelligently written. What I'm seeing is about so it's maybe it's a kind of coding actually, right? While you're putting this while in a it's called as coding.
Okay.
We have to keep on.
So when you put while inside.
We inflate loop. We usually call it as polling.
Polling.
Correct? So see how we put a register, some value, flag is there, we have keep on polling on the flag. Okay. So the flag condition changes, then we'll work it next.
Yeah.
So that whatever polling happens, right? So that much things has to be executed in the memory. This is the processor that I use register.
Okay.
Okay. So this type of experimental things are actually done in kernel.
Okay.
So they say we have things like wake up, then sleep, then wake up. Those logics are handled only the kernel. So it should be very good at the system programming, or we should ours interrupt is the only way. Interrupt is again it's hardware. When that interrupt comes, you will first handle the first and do that. You have to status. So this is how the systems are working actually now. Oriented systems. So if you give, this is a very
okay, so you can implement this.
Yeah, it is whatever.
But whenever required, you actually
is brought in here. Now, if you change like without yield, if you check the time consumption and with yield, if you type, then you understand the difference.
So I'm just writing this very small function. So let's give a call to this print command. Okay. And I'm saying 10, 20, 30. Okay. If I'm giving a call, it will obviously give me a generator function. Okay. Now this contains 3 variables. Okay. So if I say print now next of G. Okay. So till 3 times it will work fine. Okay. But if I try this next time, okay, it will give me exception, stop iteration. Okay. So this is the same iteration you actually get in case of your for loop also. But the only thing is, in case of your for loop, this exception is internally handled. Okay. But in case of generator, you have to handle this by yourself. Okay.
Sorry,
So in case you run out of numbers, okay. So I'm saying print while it contains only 3 elements. Okay. So here while printing, instead of just print, I'm saying you. So each time it will give me one number, right? So I said next, it printed 10, next 20, next 30. I'm again printing next, it will throw me exception, stop it.
so that is handled.
Okay. That we have to handle. Okay. So in case of for loop, this is the same exception it raises internally, and for loop internally handles it. So that's why it starts defaultly from start and automatically ends at the last level. But in case of a generator, it will not provide any exception handling, so you have to handle. Okay. Mukesh, now you got why we use yield.
Yeah.
Okay.
Okay.
Any queries?
No.
No. Right. So this is my generators in Python. Okay. Okay. One more thing. Okay. And the generator object is iterative. Okay. So if I write it inside a for loop, okay, I said my exception is handled internally, right? So now this is iterative also. Okay. So in short, I'm giving next call till it actually raises the stop iteration exception. But if I try the same case in case of my Fibonacci series, I will never get this exception, and my program will be continuously
So there is an
infinite. So while my while loop was infinite.
Again, you are example because the same number of variables.
Exactly. So in short, I said my for loop is my for loop handles stop iteration internally. So even if this G raises stop iteration, that is handled.
This will handle the exception, right?
Yeah. Okay. One more concept. We have seen list comprehension. Okay. Okay. I want to transform this list, but not entire. Let's go one by one. Okay. I will write my entire logic of list comprehension inside this parenthesis. Okay. Same logic. For value in L, I want value into value. Nothing new, right? Same logic, but it's just now if I print this G, I'll get the generator object. Okay. So this is called as my generator expression. So if I edit my list, I'll get the answers, right? And this will be again, if I check the type also, this will be my list, normal list, okay? But if I want a generator, okay? Now if it's generator, which means if I say now next of J, one element, two element, three element, okay? So now this is like extension of the generators inside of your list combination.
So actually, we don't use this the generators very often.
So where you have infinite numbers.
Maybe in
That's
data,
exactly. Whenever you have large computations to make, okay, you will go with your, because in that case your normal definitions are not efficient. And if it's large numbers, obviously you will not go with your list comprehension. Okay. So whenever there is a volume involved, okay, in file operations also this generators can be used. So if you see when I open my file, right, I actually get the entire string, right? So in that case also I don't want to read that entire file when I just write my read function. That case.
sorry, I don't understand.
So when we use this file operation, right? We are actually, when I say read, I'm actually reading this entire file, right? And that is entirely everything is written as a string for that. So in that case, I can go with line by line instead of reading this entire file again. Go line by line so that it will not take much time to read also. Whenever you need it, just read at time. So this is another optimization, that is generators. Okay. We will discuss exception handling. So every language support exception handling. So let's start. What is exceptions?
Interrupt.
Errors. Exactly. So we can say runtime errors to be more specific. Okay. So I have two things. One, my syntax errors. So if I say something like this in Python, this will give me the syntax error. Okay. The other thing, errors which look syntax, so the line of code which looks syntactically correct, okay, but logically this is not possible. Okay. So all such errors will come under this exceptions. Okay. So your expectation, whenever there is exception, you don't want to halt your program. First thing, that you want to continue. Let's say you want to write, if there is exception, you want to write some workaround and continue the exception first part. Or else simple method, if there is an error, in this case, whenever there is error, you are actually printing this entire stack, right? So in production, I don't want to show this stack to the end user, right? So I should show just a simple error message rather than showing in which line I got this error and everything, right? So for that, I can use my exception handling. You can do exception handling using try, catch, and I went to Java mode, try and except block. Okay. So statements which you think can throw me an exception, we will write inside of try block. Okay. Let's start with very simple example. So this is again block of code. That's why I will put code. Okay. I am saying print A. Okay. Now I haven't defined this yet. So obviously this will throw me an error. Okay. So I got this exception print date. My variable was not defined in that case. Okay. So in that case, it will throw me an name error. Okay. So I can handle this using this except block. Okay. So the way execution, now just have a look at the program flow. Okay. So first it will start execution inside your try. Okay. So it will check, it will execute. If there is an exception, at the same moment it will move to the except block. Okay, and it will start executing lines there. Okay, if there is no exception in your code, okay, now I'm getting exception because of this line. Okay. If there is no exception in your code, it will not execute the statements inside of your except block. Okay, logically makes sense also. Okay, again. If I got an exception, it will stop immediately. It will not execute this part. So it will go to this variable not defined statement. It will not execute this print another statement inside of this. Okay. Now, if I just write entire code inside this try and except block, okay, it can handle any exception. So this is not specific to anything. Okay. Okay. So now you see I'm creating the name error here. Okay. I'm creating zero division error here. Okay. And I'm saying index error here. Okay. So even I'm making this three exceptions. Okay. My single try and except block can handle all the errors. Okay. But this approach is not advisable. Okay. Because this approach is actually difficult to debug. Okay. So expected way is you will say except. Okay. And you will write the name of exception. Okay. Now this particular except block is specifically for only this. Okay. Only for handling this name error. So now if I execute this error is handled. Okay. But let's say I'm not creating this error now. Okay. But I'll get this exception. Okay. But now this exception will not be handled using this exception. It will show me the entire stack response. Okay. Because now this except block is only specific to this particular error. Okay. You can write multiple except blocks. Okay. I handled one more. Okay.
So how do you know this is accepting me?
Exactly. I'll come to that. So whenever you see, it actually gives me the name of this error. If you want a name of all the exceptions which are available, okay, you can go and check this help of underscore underscore weightings underscore. Instead of doing help actually, so help will give me the entire documentation. I'm just using this dir underscore underscore. Okay. So till now we have discussed most of the methods from this, but at the top if you see, these are some inbuilt exceptions. Okay. If you want what these exceptions are for, you can do help and you can check. Okay. So we have already seen that is so assertion, which are the ones we have seen, except we will see now. File not found is your file operation error. Okay. Generator error, IO error. So this is kind of runtime exception. We have some issue with your file. Import error if your file does not exist. Indentation error. Index error if you are specifying something which does not exist. So these are all exceptions inbuilt. Okay. So you can go through this. If you want the explanation for particular exception, you can do help of this and you can check what is it for. Okay. So the ideal way to define any exception is you will write multiple except block and you will specify the exact error. Okay. But by mistake, if there is still something, okay, so you can have one lastly one except block. Okay. So here I just say runtime exception. Okay. Now we actually don't know why this is coming. So by our knowledge, we try to handle all the exception, but still there is some exception. Okay, which means we have to go and debug it. Okay.
Usually use the switch case, right?
Yeah.
Yeah.
Yeah, we are this switch case. Yes. But still, an exception, I guess we can't use switch. Right?
That's what you see. That's how the implementation is.
Mm-hmm.
You have to take care of.
Yeah.
You have event handler kind of thing.
Mm-hmm.
Okay. So it is we are writing a wrap function, I think. And this allows all this error. Again, implementing that.
Implementing this. Okay. But you will be writing the logic.
That's a beauty of CLS. You the only thing you're ready to see everything black and white. This is really color photo. Now it is happening.
Alright. So if you want something which should be executed regardless of exceptions. Okay. So there is some part of code which you want that should get executed if there is exception, or that should execute if there is no exception also. Okay. So that can be mainly related to your if you have some resources and you want to free them. Let's say you're working on a file. So whether there is exception in that particular file, you have to close that file, or if that file working fine, then also you have to close that file. Okay. So I have this finally block.
Yeah.
So finally block will get executed always. Okay. Whether there is exception or not. Okay. So use case for this finally can be, so this finally is optional. Okay. So you can provide it, or it's okay if you do not provide it. Okay, but the use case can be you have some resources allocated. Okay, let's say you have some database connection open, or let's say you have some files. Okay? You have to close that connection, or you have to close that file anyhow, whether your operation completes successfully or there is an exception. So such part of code you can write inside of your file. Okay. So the concept of finally is, in case of socket, just closing the connections. This is okay. So this finally block will always get executed, whether there is exception or not. Let's say at particular condition you want to raise an exception. Okay. So for that I have a keyword called raise. So now you have option. You can defaultly raise your inbuilt exceptions. Okay. So just there is a keyword raise and specify the name of error which you want to raise, okay, in a particular condition. Okay. So and you have to handle this obviously. Okay. So in short, instead of Python raising the exception, you are actually raising this particular exception. Exactly.
We are actually making that call. Some other
okay.
Whether that is handled.
It's probably
It
handled.
doesn't have some callers have same thing.
Same thing. Yeah. Just write it. Exactly.
Like some messages to print
Okay. So this is the example of my built-in exception. Okay. Or you can write your custom exception also. Okay. Now writing custom exception is really easy. All I have to do, I have to write one class. Okay. Let's say you are saying value error. Okay. You can observe that all error names ends with error. Okay. And you have to extend the class exception. Okay. I don't have to write anything here. By default, I just write pass here. Okay. It's just I need to extend it from this exception. Okay. So now I'm saying raise value. Okay. And I will handle it. Except value. Where this is getting this syntax is ready for must be. Oh. Yeah. Okay. So either you can raise inbuilt exception using this raise, or you can write a custom exception. So ideal way is all your custom exceptions you will write in separate file. Okay. So your entire file will contain only exception, and you will raise the exception.
So after we handle all this, right, do we use it, oscillate this
Which one?
Like,
So this particular program, which are the exception it is
yeah.
handling?
So is there something like we can give a kind of thing?
Mhm.
So exceptions handle.
Okay. Okay.
Something is there because we have signals in there.
Uh-huh.
Saying it.
Uh-huh.
So we know that memory corrections happen or divided zero
Uh-huh.
happen. Something that happen. And that is actually characterized on outside the program. Not outside the runtime. The program is executed, but that information is characterized outside the program. So we give
So you know that inside the program, which are all the exceptions which are
Yeah.
already handled. So in short, it's kind of a program which works as a documentation also.
correct. So is there some use there where we can see that? Because that will be a useful thing, right? You just suddenly just type a command and you say, okay, this is
So these are the exceptions which are already handled.
Is there something like that?
I'm not aware of. Okay, not aware of. Okay, but I'll go and check this thing.
No, this will be usually because we cannot run the situations might be like this, where something has happened only once in the real time.
You cannot handle that particular
See,
exception.
that's we have handled it and the one. But whether that in instance is captured somewhere outside here, using Python environment only, these are the exceptions occurred.
Okay.
Give them command, these are the exceptions occurred and this one. So it can be a real time
Monitoring system.
so if you instead of going and seeing some log files and all those things, so if you just give this one, you can say that this program, this exception is occurred, this program, this exception is occurred. So this
Let
will
us
be
check if there is any library or
useful.
not for that. Is there any library for that or not?
Yeah, because that will be a very exact. If you go for any rate, if you go for large numbers, we get or something. You will get some number will be captured because of that thing has not been captured. And again go to database and search and all. So instead of that, okay, this last type program, this exceptions happen.
So these are the 5 runs, and in last 5 executions, these are the executions which are not.
Usually the last term, you don't use the last one. So there are where are the memory characters happen. Will give us the runtime or which are processors for which the memory characters happen. So we will give this type of things. It can be that's a very because this is are really time consuming activities.
Just going through the logs.
So where kind of things can be used because one of the where we save the real time knowledge, they ask this type of question. We'll have a time 10 say, give me this, only this one. 10 days they'll ask city. We have to find out.
So this is my exception handling. I'll specify try block, except block with the error. Okay. And whatever code I need to do if this there is an exception. Okay. Finally, I will specify one default block, and it should be at the exception. Okay. There is one optional block. This is finally, so it will execute regardless of the exception. Okay. So if you want to raise any exception, we can use this raise and the exception. So 2 things, either you can use built-in exceptions or you can define them. Yeah, it will. Yeah. So this is my exception handling. Okay. So we'll stop here. Next time we will start with XML and JSON processing, and then HTML processing.
Kunal,
Yeah.
send this Python file to my Gmail.
Okay. Sure.
Thank you.
Yeah. Thank you.
Bye bye.
Bye.
Right.